Alright, I jumped ahead a little bit in the examples just to get to a few more. It says, test prep, a GRE company claims the average score improvement of their students is equal to 90 points, no more or no less. We randomly sample students for their average improvement. The data collected is below. So here we've got a data set. Evaluate the company's claim using a hypothesis test. You wish to test the following claim at a significance level of alpha equals 0.05. Notice here I don't have my stuff set up. Oh, popped it over to the other screen. That's pretty useful. Maybe here. Okay. And Excel. Alright. So I did get that last one right. I forgot to click on the answers here. So we've got some stuff here. A couple of things. Our data set, important, alpha here. So I'm going to add some of this. I think I got an extra 0 there. So when it says test the company's average score improvement of their students is equal to 90, no more or no less, that's giving us both the null and the alternate, the no more, no less. So it's just different than is going to be our alternate hypothesis. Okay, so grabbing our data set here, and I'll leave a little room, I think, and I'll try to paste special again, just the text. Grabbing here, n is 10, which means our degrees of freedom is 1 less. Now you might be like, why in the world are you doing this with Excel? I can subtract 1. You can, and that's fine. This gives me evidence a little bit that I know what I'm talking about. Maybe I don't. Maybe I do. Oh, mu from the null. And I want that guy, 90. Now, x bar. Again, we're using our data set here. Got the average. Grab these guys. Now, one thing as you're doing these, sometimes it can be easy to have the data set slide or not grab the right things. So as I'm checking work here, if I click on these and you do these and I notice you just grabbed the wrong thing by chance, you might still be able to get a majority of the points. Now I got to undo what I just did. And I need my standard deviation of the sample. So standard deviation of the sample, again grab the data set. I feel like we should be getting close here. We've got alpha, we've got n, we've got this, we've got x bar, and we're different than. So I can draw a picture here, my x bar 82.6 and my mean 90. So 90 is going to be in the middle. So here's my 90. And I don't really know for sure perspective wise, but 82.65 is going to be over here somewhere. I don't really know how many standard deviations. And this was different than, so it's two-tailed. So I'm going to have this guy and this one. So, standard error up next. Just wanted to get a picture there. We use the standard error to find the test statistic. So it's the sample standard deviation divided by the square root of the sample size. Grabbing those guys, putting them here. And I've kind of crowded mine here. The test stat is going to be, get some grouping symbols, x bar minus the mean, mu, over the standard error, which it won't let me grab. So I'm going to grab this guy and then just go down 1. I'm not sure. I think that might be because I'm recording. A little bit of a hiccup here. Doesn't always do that, but it started to recently. Okay, so haven't even checked down here what more I need. This is a two-tailed test. The p-value, okay. P-value is the next important value here. And if I start doing t-dist, notice I have some options. T-dist, two-tail, t-dist. This is a left-tailed test. So keeping with the old school, I would do, we have a negative test statistic. It's not a left-tailed test, but it's a negative value. So I can do t-dist, grab the test stat, put in the degrees of freedom, and say true, and I double it because I want it two-tailed. So this is the old school, making the link to the stuff and using our picture here. And notice here, 0358. I might need some more decimals if I'm going to make this accurate to 4 decimal places. So 0.035. The 7 is followed by a 9, so it really is an 8. And we're good there. Now, why do we even have this t-dist two-tail if we're not going to use it? If we are going to use it, this guy needs to be positive. For whatever reason, it does not like negative test statistics. And I think it's because of the way it's built. So anyway, you can do the absolute value and then grab this. And then I close, and then I've got my degrees of freedom and that. So I don't love the t-dist two-tail because it always has to have a positive test statistic. And also, it doesn't quite link to what we were previously learning as well. So we have to compare this value to this value, and our p-value is less than alpha, so our decision is to reject the null hypothesis. If we reject the null hypothesis, then there is enough evidence at alpha equals 0.05 level to say the average improvement is not 90 points. And so, again, it's just different than 90 points. We don't know whether it's higher or lower. We click on this, and we got it. Okay, so it's just another example I wanted to run through. And maybe look at this one here. A donut company says their donuts remain fresh for over 3 days on average. So over 3 days on average means they're going to think it's greater than 3. So when you go down here, you have to start using the language in there to decide which we have here as our null and alternate hypothesis. Again, the null hypothesis is always that it is something, and then greater than 3, we're going to be here. We're going to be right-tailed. I'm going to use this data to find the same stuff we have here. So I'm not going to quite run through the whole process. I just wanted to talk through them a little bit because we have a lot of different types of questions, and some of it's just the language here and understanding what's what. But you should at this point, you've practiced this with normal distributions, and now we're coming back to it with means, changing up things a little bit, but just updating the info we have here using these guys instead of the ones we had in the last module. So again, we have some more functions we can use. You can always kind of use the t-dist and use the same systems you had with the normal distribution to make it all work. Obviously, slight change of pace to degrees of freedom, but again, Excel sort of prompts us for those. So hope that's helpful for you. Let me know if you have any questions. Good luck.